Chemistry with withsarwatAhmed. In this video I will solve paper 1 multiple choice Feb March 2024 970112. This which species contain the same number of neutrons as carbon and the same number of electrons as sodium? Same number of electrons with carbon. Carbon has 8 electrons. 14 minus 6 is equal to 8, and in this case and same number of electrons, same number of neutrons and same number of electrons, so 10 over here. So in this case neutron is neutrons have the same number of 9 or 8 neutrons, same number of neutron as this, and electrons are, this is positive, so this is 9 or 8 17, no, 9 or 8 17. Electrons are 9, and in this case neutrons are, this is 16, 15, 7, 8, 9, and electrons are 10, so this is incorrect. Neon is 10 neutron and 10 electron, and in this case 10 electron and neutron is 8. Neutron is equal to carbon and electrons are equal to sodium ion, so that's why this is correct. Which process has the largest enthalpy change per mole? Aluminium 3 plus and 4 plus. Protons are 13 and 2 8 10. So this is the next shell, has the largest enthalpy change per mole. This is the next shell, P5 plus P6 plus electrons. This is also next shell, S6 and S7. So this is 6 positive and this is sulfur. Enthalpy change per mole is the largest because ionization energy is increased across the period. So this is the largest enthalpy change per mole. 1 mole of electron is removed from the second shell. So sulfur is present in group 6, so that's why enthalpy change per mole is increased across the period. So C is the best option. Which sodium compounds contain 74.2% by mass of sodium? Sodium carbonate is like this. Which sodium compounds contain 74.2% by mass? By using this 46 divided by 100 into 100, 46%. This is 23 divided by 58.5, 39%, and this is 23 divided by 40 is equal to 0.57%. So this is the best option. So D is the best option. What is the maximum volume of sulfur dioxide gas measured at room temperature from burning 100 dm cube of diesel fuel containing 0.346 gram of sulfur? We know that 100 dm cube has this mass of sulfur, and what would be the N24? So first calculate the MR of so this is not. First calculate the MR, mole. This is the mole of sulfur, 0.8346 divided by 32, and we get 0.026. So we know that 1 mole is equal to 24,000 centimeter cube volume. 1 mole of any gas occupy 24,000 centimeter cube. So what would be the volume of gas if 0.026 moles are there? So this is equal to, by using cross multiply we get 624. So 624 centimeter cube is the answer. Which row shows the correct number of covalent bonds in molecule of methyl propane? So this is one is the pi bond, this is the pi bond, and rest are sigma bond. So 1 2 3 4 5 6 7 8 9 10 and 11. So C option 11 sigma bond, and 1 is the pi bond. Question number 6. Aluminum chloride Al2Cl6 molecules at room temperature, when heated to a high temperature, AlCl3 molecules are formed. What are the arrangement of the bonding pairs of electrons around the aluminum atom in the two forms of aluminum chloride? So this is the Al2Cl6 structure. So AlCl3 molecules are formed. What are the arrangement? Electrons around the aluminum atom in the two forms of aluminum chloride. Aluminum chloride has trigonal planar AlCl3. So this is planar structure, and in this case aluminum is bonded with 4 atoms, 1 2 3 and 4. So in this case tetrahedral. So B option is correct, planar and tetrahedral. The table shows the physical properties of 4 substances. Which substance has giant covalent structure? Giant covalent structure should be Cn, because this is low melting point. Giant covalent compounds have high melting and boiling point. So this is minus 119, so these are incorrect. So 993, melting point high, boiling point high. Electrical conductivity poor in solid. Electrical conductivity of liquid good, this is incorrect. And electrical conductivity of aqueous solution cannot conduct electricity, so this is also incorrect. So D option is correct, because high melting point, high boiling point, poor electrical conductivity of solid, poor electrical conductivity of liquid, and electrical conductivity of aqueous solution is also, because giant covalent compounds are insoluble in water, so that's why D option is correct. At room temperature and pressure, water is a liquid and H2S is a gas. Water is a liquid, H2S is a gas. What is the reason for this difference of state? A option, O has a higher first and second, oxygen has a higher first and second ionization energies than sulfur. So ionization energy does not matter in this case, that the temperature, why it is liquid and why it is solid. So this is why it is incorrect. The covalent bond between oxygen and hydrogen is stronger than the covalent bond. So covalent bonds are always stronger, whether it is in between hydrogen and oxygen or whether it is sulfur and hydrogen. So there is a significant hydrogen. Oxygen is more electronegative than sulfur, so that's why when oxygen react with hydrogen atom form hydrogen bonding. So there is permanent dipole force in H2S, but not hydrogen bonding in H2S. So that's why the reason is in between H2S and H2O is the significant hydrogen bond between water molecules, but not between hydrogen sulfide. So C option is correct. The instantaneous dipole induced dipole forces between water molecules are stronger than the instantaneous. So there is no instantaneous dipole forces in water. There is permanent dipole and hydrogen bonding in water. So that's why it is also incorrect. Question number 9. The enthalpy change for the reaction can be calculated from values of enthalpy change of formation, enthalpy change of combustion, and bond energies. Enthalpy change of the reaction given is equal to delta HR. So this is delta HR. So if we by using Hess law, if we use this triangle, over here and this is over here, and this is indirect route and this is direct route. H1 is equal to H2 plus 2H3. So this is 2H2 because 2 moles are there. So it should be 2H2 and plus 2H3. So delta HC, this is not possible, C2H6. So this is C2H6 gaseous state combustion. So delta HC, C2H6, that is H2, that is the H2, and this is 2, and minus because H2 is the subject, H2 is the subject, and this is 2H1 2H1 minus H2 is equal to 2H1 minus 2H3. So this is 2H1 and this is 2H3 minus 2H3, CH4. So B option is correct. Which is incorrect because 2 moles of carbon to carbon double single bond. So that's why this is also incorrect. Carbon and 4 moles of 2 bonds of carbon to oxygen. So this is also incorrect. And over here this is 1 delta HF of CH4, 2 should be there and 2 should be there. This is also incorrect. So B option is correct option. Which reaction has enthalpy change equal to the standard enthalpy change of formation of propane? Enthalpy change equal to the enthalpy change standard enthalpy change of formation. So this is 3 because enthalpy change of formation is defined, can be defined as 1 mole of propane is formed from its constituent elements in their standards from their constituent elements in their standard states under standard conditions. So this is not standard state, so that's why this is incorrect. This is also not standard state. Carbon is, it should be in solid state. So these two are could be correct. 3 carbon solid, 4H2C3H8, 4H2 1 mole is there. So this is gaseous form and this is liquid form. So this is correct, but this is incorrect because the state symbol of propane is gas at room temperature and pressure. So that's why C option is correct. One of the reactions in the rechargeable lead acid battery is shown. Which statement about this reaction is correct? Lead is both oxidized and reduced. So over here lead PbO2, this is equal to 4, and in this case lead carrying 2 positive, sulfate carrying 2 negative. So that's why PbSO4. So lead carrying 2 plus charge, and over here 0. From 0 it is going to 2 plus, and plus 4 it is going to reduced. In this case reduced, and in this case oxidized. So that's why lead is both oxidized and or reduced. A option is correct option. Question number 12. KMnO4 is an oxidizing agent. Its reaction with Fe2 plus is shown in the following ionic equation. What are X, Y when equation is balanced? We know that over here MnO4 oxygen, so first balance the oxygen atom. So here, because over here oxygen is 4, place over 4 over here, and when 4 over here, place 8 over here. 4 to the 8, or hydrogen ion is balanced with 8 moles. And similarly, because iron 2 so we know that if MnO4 over here plus 7 and over here plus 2, the change in oxidation state is 5. So 5 electrons are there. So we know that Fe changes into 3 positive plus electron. So this iron is multiplied with 5 Fe 2 plus to form 5 Fe 3 plus 5 electron. Electrons are cancelled out over from here and here. So that's why 5 is placed with iron 2 and 5 over here. So in this way X is 1 and Y is 5. So C option is correct option. Question number 13. Nitrogen and hydrogen are mixed in the reaction vessel. The reaction reaches equilibrium, giving a mixture of nitrogen, hydrogen and ammonia gas. The mixture of gases present at equilibrium at a total pressure of 300 atmospheric is shown. So total mole of this reaction is 930, and partial pressure of N2 is equal to 18 over 930 into 300, and which is equal to 58.1 atmospheric, and for pressure of hydrogen is 590 over 930. This is into 300. Or similarly, partial pressure of ammonia is 160 over 930 into 300. This is equal to 51. This is equal to 190, and this is equal to 58.1. So what is the equilibrium constant Kp for the forward reactions? Kp is equal to product over reactants. So products are 51.6 whole square and 58.1, 190.3 whole square. So the unit is because 2 from here cancelled over here, and 1 from 3 minus 1. So that is 1 over ATM. The unit is ATM minus 2, and the answer is 6.65. So this is incorrect, this is incorrect, and 6.65 into 10 raised by 2 minus 6, ATM minus 2. So A option is correct. The mixture of hydrogen gas and iodine gas is placed in a reaction vessel of volume V at temperature T. The reaction H2 plus I2 to form 2HI is allowed to come to equilibrium. All substances remain in the gaseous state. Argon gas is then pumped into the reaction vessel. The temperature in the vessel is maintained at T. How are the rate of the forward reaction and the partial pressure of HI equilibrium affected? The temperature in the vessel is maintained at T. Argon gas is then pumped into the reaction, it means pressure is increased. So the rate of forward reaction is unaffected, and the partial pressure of the, because the rate of forward reaction is unaffected and partial pressure of HI at equilibrium is unaffected, because both sides have, by increasing the mole, by increasing pressure, the equilibrium is shift the side with less number of moles. But over here 2 moles on the reactant side, 2 moles, so that's why rate of forward reaction is unaffected, and partial pressure of HI at equilibrium is also unaffected because both sides have same number of moles of molecules. So D option is correct. Two experiments are carried out to study the reaction between zinc and sulfuric acid. Experiment 1, small lumps of zinc are added to excess dilute sulfuric, small lumps. Experiment 2, the reaction is carried out at a lower temperature and with one other change. Lower temperature with one other change. Over here small lumps and excess of dilute sulfuric acid. Both experiments produce the same total volume of the gas and are completed in the same time. What is the, over here lower temperature, but over here small lumps of zinc are added at lower temperature with one other change. So what is the second change made in experiment 2? Catalyst is added to speed up the rate of reaction, and you know that there is no change except decreasing the temperature. So when decreased temperature, when you add catalyst, it speed up the, it increases the rate of reaction, and the same amount of gases, same volume of gases evolved at the same time. So that's why A option is correct. Greater mass of zinc is added more because zinc, he's saying that excess dilute sulfuric acid here, so zinc is limiting reactant, so that's why when you increases the mass, so more volume of gas is produced, so that's why it is incorrect. A greater volume of sulfuric acid is added. No effect with greater volume of sulfuric acid is added because sulfuric acid is already excess is using over here. Larger lumps of zinc are used. So larger lumps of the reaction is too slow as compared to this. But catalyst is the best option. A option is good option for this reaction. The relative magnitude of the property X of 5 elements is shown. P, Q, R, S and T are all in the period 3 and have consecutive atomic number. The letters are not the actual chemical symbols of the elements. Look here, P, Q, R and S and T. So this is consecutive atomic number. P, Q, R, S and T are all in the period 3 and have consecutive atomic numbers. Which row is correct for property X and element R? Element R is here. Electronegativity is not high in case of silicon. Silicon is less electronegative. Melting point is higher, but not silicon is higher. Silicon should be at this place, aluminum at this place in case of melting point. So that's why it is also incorrect. Second ionization energy of silicon across the period ionization. This is not second ionization energy of silicon. This is not the graph of ionization energy, so that's why it is also incorrect. So first electrical conductivity, so aluminum is and silicon is R is silicon. R could be silicon. Silicon is because aluminum has higher, more number of delocalized valence electron, so that's why aluminum is more electrical conduct. has because aluminum has this is sodium, this is magnesium, and this is aluminum, has one delocalized electron, has two delocalized electron, three delocalized electron. So aluminum has more delocalized electron. The strength of electrical conductivity depends on the number of delocalized valence shell electron. So that's why it could be A. Element X in period 3, element X reacts with oxygen to produce solid Y. When solid Y is added to water, a solution with a pH of less than 7 is produced. What is the identity of element X? Element X reacts, sodium reacts with oxygen to form sodium oxide, but sodium oxide in solid state. Sodium oxide dissolves in water to form sodium hydroxide. It increases its pH, so that's why sodium is incorrect option. Silicon is also react with oxygen to form silica, and it's insoluble in water. It is insoluble in water. So that's why it is also incorrect. Phosphorus could be the best option because phosphorus react with oxygen to form phosphorus 5 oxide and dissolves in water to form phosphoric acid. So that's why phosphorus is the best option. Sulfur and it exists in solid state. He asked that when solid Y is added to water. So this is also correct because it decreases the pH, but when dissolved in water form H2SO3, but sulfur dioxide exists in gaseous state. So that's why it should be in solid state. So phosphorus 5 oxide exists in solid state, that's why it is correct option. So this is also incorrect. The questions 18, question number 18. This question refers to isolated gaseous species. The species fluoride, neon, sodium are isoelectronic. Isoelectronic means same number of electrons. This is 10, 10 and this is 10. This means that they have the same number of electrons. In which order do their radii increases? You know that cationic radius decreases across the period, but anionic radius increases across the period. So overall we can say generally ionic radius increases across the period. So sodium is the smallest, fluorine, neon. So this could not be the case because fluorine should be here, fluorine ion. So this is sodium neon atom. So this is also incorrect. Fluoride has largest, neon and sodium is smallest. So sodium has the smallest, neon, then after sodium there will be neon, and fluoride is the largest ionic radius. So that's why C option is correct option. Separate samples of magnesium and calcium are added to an excess of dilute sulfuric acid. The observations are summarized in the table. Magnesium vigorous reaction, yes, bubbles of gas produced. Magnesium completely dissolves. This is correct. Calcium vigorous reaction, calcium react with sulfuric acid. Vigorous reaction initially, bubbles of gas produced, yes, correct. Soon stop reaction and leaves most of the calcium unaffected because immediately precipitates of calcium sulfate is formed which hinder the further reaction. For example, this is the calcium and calcium sulfate cover, solid calcium sulfate cover this calcium which hinder the further reaction of calcium with sulfuric acid. So that's why most of this is correct reason. Which statement explains the difference in these observations? Calcium is better oxidizing agent than magnesium. Both are metals, so both are good reducing agents. So calcium is better, could be better reducing agent. So that's why it is incorrect. Calcium is better reducing agent than the magnesium. Yes, calcium is better reducing agent than the magnesium, but here the reaction added to an excess of dilute sulfuric acid. So that's why it is also incorrect. Magnesium is less reactive. Magnesium is more reactive, so over here is less reactive metal with all dilute acids than calcium. Magnesium is more reactive, less reactive metal with all dilute acids than calcium. So this is not correct with calcium sulfuric acid. It is reactive, vigorous reaction, but due to the formation of precipitates, it become unreacted. It will become unreacted due to the no further reaction with sulfuric acid. So that's why it is also incorrect. Not with all, only dilute sulfuric acid cannot completely react with calcium. Magnesium sulfate is more soluble. This is correct reason, because magnesium sulfate is more soluble than calcium sulfate, because solubility of sulfate, group 2 sulfate are decreased down the group. So only magnesium sulfate is soluble, calcium sulfate is insoluble, strontium sulfate is insoluble, and barium sulfate is most insoluble. So the reactivity solubility is decreased downward. So that's why D option is the best option. Dolomite is double carbonate, so this is like calcium carbonate and magnesium carbonate, and can be used instead of calcium carbonate for treating acidic soils. The three statement all refers to the agricultural use of these carbonates. Dolomite and calcium carbonate are both less soluble than calcium hydroxide. Yes, it is correct, because solubility of group 2 hydroxides increases downward. So 1 mole of this is correct statement. 1 mole of dolomite has the same neutralizing effect as 1 mole of calcium carbonate. So this is incorrect. 1 mole of dolomite needs 2 moles of sulfuric acid. So that's why this is also incorrect. 2 moles of sulfuric acid is used to neutralize these carbonates. Number 3 is dolomite and calcium carbonate both increases the pH of acidic soil. Yes, it is correct. Dolomite and calcium carbonate both are equally used to neutralize the acidity of the soil. So that's why both increases the pH of acidic soil. So that's why this statement is also correct. These statements are correct. So that's why in this case B option is correct, because 1 and 3 are correct. Question number 21. This question is about two salts, sodium iodide and sodium chloride. The two solid salts separately added to form concentrated sulfuric acid, and the results noted. Aqueous solutions of two salts are separately added to silver nitrate, and then concentrated ammonia is added to the result needed. Identity of one of the product formed with concentrated sulfuric acid. This is not one of the product. So this is HCl, and when added in hydrogen chloride after this reaction, colorless solution is formed. When we add silver nitrate and then afterwards ammonia solution, silver nitrate with silver nitrate, white precipitates are formed which are dissolved with addition of ammonia. So that's why it is incorrect. Cl2 is incorrect. This is colorless solution form, it is correct. Sodium chloride H2S, no, H2S is formed in this reaction. White precipitates are formed with dissolved. This is also incorrect. Sodium iodide H2S is formed. Yes, H2S is formed. Sulfur dioxide is formed with this reaction. I2 is formed in this reaction. So many products are formed in this reaction, and sodium iodide reacts with concentrated sulfuric acid. So yellow precipitates remain insoluble with addition of ammonia. So that's why C option is correct option. Yellow precipitates are formed, and sodium iodide, iodine is correct. Colorless solution is incorrect. So that's why C option is correct. The diagram shows the process of adding calcium nitrate and strontium nitrate to separate boiling tubes and heating them. Identical conditions are used. Calcium nitrate, water containing universal indicator, strontium nitrate. By heating strontium nitrate, water containing universal indicator. As the reaction proceeds, the water containing universal indicator changes color. Which row describes the color change? Identifies the nitrate that causes the quickest color change. We know that thermal stability of group 2 nitrates are increased down the group. So if it is increased down the group, so calcium nitrate quickly decomposed to form nitrogen dioxide and oxygen gas, and nitrogen dioxide is brown colored gas, and water containing universal indicator changes color rapidly than with the strontium nitrate, because strontium nitrate afterward the calcium nitrate in group 2, so that's why strontium nitrate is more stable than the calcium nitrate. Green to blue is not correct. Green to blue also incorrect. Quickest is calcium nitrate is the quickest, and strontium nitrate not quickly, because strontium nitrate is more stable than calcium nitrate. So green to blue color change is incorrect. Green to red color change is correct, and calcium nitrate is also correct, because calcium nitrate is less stable, required less heat, and decomposed quickly. Green to red correct, but strontium nitrate is incorrect. So C option is correct option. The equations for the three reactions involving chlorine or its compounds are listed. 2KClO3 to form potassium chloride and oxygen, 2KClO3 to form KClO4, KCl, KOH plus Cl2 plus water to form KCl and KClO3. Which statement about these equations is correct? Equation 1 describes the formation of compound used to kill bacteria in drinking water. So it is incorrect. KClO. ClO is the species which is used to kill the bacteria in drinking. ClO. If ClO is formed, then this is correct, but over here KCl is formed, so that's why it is incorrect. Equation 1 does not represent a redox reaction. Equation 1 doesn't represent a redox reaction, because over here Cl3 plus 5, and over here minus 1. So this is redox reaction. Equation 2 describes the formation of potassium chlorate 4. Equation 2 not 4, it is potassium chlorate 7. So that's why it is also incorrect. Equation 2 and 3 both represent disproportionation reaction. Yes, both 2 and 3 disproportionation reaction, because chlorine is both oxidized and reduced at the same time. So that's why it is disproportionation, and in this case chlorine is also oxidized and reduced. Over here minus 1 and over here plus 5 oxidation state. So you know that how to calculate the oxidation state of the underlined element. For example, this is equal to 0, potassium carrying 1 plus x plus 3 minus 2 is equal to 0, 1 plus x minus 6 is equal to 0, x minus 5 is equal to 0, x is equal to plus 5. So that's why how to calculate the oxidation number. So this is minus 1, it is carrying plus 5. So D option is correct. Nitrogen monoxide is primary pollutant produced by the petrol engines and is found in their exhaust gases. Which reaction occurs in a catalytic converter and decreases the emission of nitrogen monoxide? Nitrogen monoxide, carbon nitrogen dioxide, this is incorrect option. Nitrogen monoxide, this is not going to take place in the catalytic converter, so that's why it's incorrect. This reaction takes place in the catalytic converter. Nitrogen monoxide, carbon monoxide, both are harmful gases. When passed through catalytic converter, it changes to less harmful gases, nitrogen and carbon dioxide. So that's why it is this reaction takes place in the catalytic converter. So C option is correct option. Nitrogen monoxide, carbon dioxide. So this is also wrong reaction. It does not take place in the catalytic converter. The diagram shows, question number 25, the diagram shows the structure of the naturally occurring molecule cholesterol. This is cholesterol structure. Student X stated that the 17 carbon atoms in the 4 rings all lie in the same plane. Yes, because they are they having sp2 hybridization over here, sp2 over here, sp2 over here, sp2 sp2, so that's why they all lie in the same plane. 17 carbons are there and they all lie in the 4 ring, all lie in the same plane. Student X is correct. Student Y states that this molecule displays cis trans isomerism at the carbon to carbon double bond. This could not be cholesterol. So student Y is incorrect, because by rotating this, carbon to carbon double bond is going to break, so that's why student Y is incorrect. Which statements are correct? Both state student, this is incorrect. Student X not student Y. Student X only correct. The drug cortisone has the formula shown. In addition to those chiral carbon 1, 2, 3 marked by an asterisk, how many other chiral centers are present in the cortisone molecules? So there are over here chiral carbon. This is chiral carbon because this is surrounded by 4 different groups. This could be chiral carbon. This could be chiral carbon because it is also surrounded by 4 different groups, and this is also a chiral carbon because this carbon is surrounded by 4 different groups. So that's why 3 more chiral carbons are there. So the option is D. But2ene reacts with cold acidified potassium manganate to give product X. But2ene reacts with hot concentrated acidified potassium manganate to give product Y. Which statement about product S, X and product Y is correct? So this is but2ene, this is but2ene. This is but2ene. When react with cold acidified potassium manganate to give carboxylic acid, CH3 is 2 moles of carboxylic acid, and cold dilute, sorry, this is diol, formed is diol, sorry. Diol is formed in this case with cold, and with hot, with hot 2 moles of carboxylic acid is formed. Both product X and product Y will react with 2,4-dinitrophenyl hydrazine. This is carboxylic acid, this is diol. Both cannot react with 2,4-dinitrophenyl hydrazine. So this is incorrect. Neither product X nor product Y will react with 2,4. Yes, this is correct because this is carboxylic acid and this is diol. Product X will react with 2,4. Product X will react. No, this is diol, so it cannot react with 2,4-dinol, and product Y will not. This is, and this is correct. So that's why C is incorrect. Product Y will react with 2,4-dinitrophenyl hydrazine, product X. So this is also incorrect. So neither product X nor product Y will react with 2,4-dinitrophenyl hydrazine, only react with this is the confirmatory test of carbonyl group. So 2,4-dinitrophenyl nitrophenyl hydrazine react only with carbonyl compounds. A sequence of reaction takes place. The major product compound Z. Propanoic acid, so lithium aluminum tetrahydride is a reducing agent which reduces propanoic acid to form propanol. This is 1 propane 1 all. Concentrated sulfuric acid, water is eliminated from this reaction to form prop 1E. So this is the compound Y, and when this compound propene pass vapors with steam over H3PO4, again this is he asked you the major product is formed. This is unsymmetrical alkene, so that's why there are two products are formed. One is CH3 CH2 CH2OH, this is the minor product, and the other product is CH3 CHOH and CH3. So this is the major product. So that's why compound Z is the this compound CH3CHCH3. This is over here CH3. So this is secondary alcohol is formed. Secondary alcohol is the major product. What is the compound Z? Compound Z is propan 2-ol. The name of this one, 1, 2, 3. So at 2 carbon OH is attached, so that's why this is propan 2-ol. Which statement is correct? Bromoethane. This is bromoethane, CH3 CH2Br. React with sodium hydroxide aqueous to form ethene. Yes, is the major product. CH2 CH2. Bromoethane react with sodium hydroxide to form ethene as the major product. No, because this is unsymmetrical alkene, this is only one product is formed. This is symmetrical alkene, sorry. Symmetrical, and this is only one product is formed, not mine and not major. 1 chlorobutane reacts with more rapidly than 1 bromobutane. Yes, this is correct because CBr 1 chlorobutane react with more. This is incorrect because CBr bond is bond length is increased, so less energy is required. This is more reactive than the CCl bond. This is more reactive, so that's why it is incorrect. Hydrolysis of C2H5C. This is C2H5 CBr. This is tertiary haloalkanes. So occurs mostly by the SN2 mechanism. So tertiary haloalkane is more stable than secondary and then primary. So that's why it exhibits SN1 reaction, not SN2, and takes place in 2 steps. So that's why it is also incorrect. This is primary carbocation is less stable than tertiary carbocation. This is tertiary carbocation and this is primary carbocation. So that's why this is correct, because tertiary carbocation is less stable. It is more reactive. In other words, we can say tertiary carbocation is more stable carbocation. So more stable due to more inductive effect, more alkyl groups are attached. So that's why causing more stable inductive effect. So that's why D option is correct. In the hydrolysis of bromoethane by aqueous sodium hydroxide, what is the nature of the attacking group? This is the nucleophile and a leaving group. Leaving group is also nucleophile and attacking group is also nucleophile. So attacking group is nucleophile, leaving group is nucleophile. So D option is correct. X is an organic compounds containing the elements carbon, hydrogen and oxygen only. The table shows the observations made from 3 chemical tests carried out on X. Sodium, yes, alcohol, sodium react, sodium carbonate can react, and this is what is possible structure of X? X is hydrogen. The table shows the observation made from 3 carbon chemical tests carried out. So this is also oxidized, OH is also oxidized to carboxylic acid, so remains orange. So this test is Not true. In this case, this is aldehyde and this is alcohol. Sodium can, sodium carbonate cannot, and Cr2O7 can. So that's why it is incorrect. C. So this is aldehyde, this is tertiary alcohol. Sodium can, sodium carbonate cannot, and Cr2O7 cannot. So this is aldehyde, so chromate can be. Okay. Sodium can react because alcohol is there, and sodium carbonate is correct. It can react. So this test is correct. This is also correct, and this case, because this is tertiary alcohol, so tertiary alcohol cannot be further oxidized, so cannot react with. So Cr2O7 remains orange. So D option is correct option. So that's why. Okay. So all these observations are correct in this case. Cr2O7 remains orange. How many moles of oxygen gas are produced are needed for the complete combustion of 1 mole of CH3 3COH? This is butanol. CH3, CH3, CH3 plus 4 to the 8, 8 or 5, 13, 13, 6 to the 12, 6 to the 12 and 1 13. So A option is correct. In which pair will each compounds give different visible result with alkaline iodine? Different visible with alkaline iodine. This is CH3CH2OH. This gives alkaline iodine, and this is also double bond OH, also gives. So both gives, and in this case both gives ethanol and propanol, both gives a positive result with alkaline iodine. CH3COOH, this will give, this will not. C2H5, this can be, because this is like this, CH2 CH3. Different visible with alkaline iodine. and this will give different C11O C2H5. So D option is correct. Which reagent gives a positive result with propanol alkaline iodine? Yes, this will give the positive test with alkaline iodine. Aqueous bromine, no. Failing reagent does not. Tolerant reagent. This is propanol. Propanol gives negative test with failing bromine and tolerant reagent. Bromine gives positive test with alkene, and failing and tolerant reagent gives with aldehyde. So this is ketone only gives with alkaline iodine. So A option is correct. Esters can be hydrolyzed with an aqueous alkali or an aqueous acid to form two products. The table compares the two methods. Esters can be hydrolyzed with an aqueous alkali or aqueous acid to form two products. The table compares the two methods. Aqueous alkali, complete conversion to salt and organic acid with aqueous alkali. Yes, this is correct. Forms an equilibrium mixture with a salt and an inorganic. No, this is incorrect. Complete conversion to salt and an alcohol. This is also correct. Complete conversion to salt and an alcohol. No, yes, this is correct. So these reactions are reversible, irreversible. All reactions are irreversible. Forms an equilibrium mixture with an organic acid with aqueous acid and an alcohol. Yes, this is correct. Complete conversion to a salt and an alcohol. This is incorrect because this is not complete conversion. Forms an equilibrium mixture with an organic acid and an alcohol. Yes, this is correct because this is a reversible reaction when the hydrolyzing with acid, and it forms an equilibrium mixture with an organic acid and an alcohol. And in this column this is correct, so C option is correct option. Structural isomerism only should be considered with answering this structural isomerism. How many compounds with molecular formula C5H11B are primary haloalkane? So this is first compound, and this is 1 2 3 4. This is primary, this is primary, and this is also 1 2 3 CH3. This is also primary, and 1 2 3 4. Four carbon CBr and one in this, one in this, 1 2 3 4 5. Secondary 1 2 3 5. 1 2 3 4. 1 2 3. 1 is this, 2 is this, 3 is this, and 4 is this. So 1, 2, 3 and 4 isomers. So that's why 4. Question number 37, compound Z is formed. Compound Z is formed by the reaction scheme shown. CH3CH2CBr, cation is in ethanol. CH3CH2Cn is formed. Reflux with dilute HCl. Compound Z is CH3CH2COOH. Propanoic acid is formed. So it is not correct. This is not correct. This is ethanoic acid, which is not correct. CH3CH2, this compound is formed. So D option is correct. Hydroxyethanol is heated under reflux with an excess of acidified potassium dichromate until no further oxidation takes place. What is the skeletal formula of the organic product? So this is 1,2-diol, and there is 2 carbon. 1, 2, 3. This 3 carbon, it is incorrect. 1, 2. But this is alcohol only. This is alcohol and this is carboxylic acid. Because under reflux with acidified potassium dichromate, both alcohol are oxidized to form dioic acid. 1,2-dioic acid, ethanedic acid. So this is 1, 2. And this is carboxylic acid. This is another carboxylic acid. So B option is correct option. The formula shows the repeat unit of an addition polymer. This is the structure of. This is the structure of. This is the polymer, and from this polymer this monomer is formed. 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is pent-2-ene. So this is a compound name. The infrared spectrum of a compound is shown. Transmission percentage. So this is transmission. So this is 1710 is carbonyl group, and 1710 is the 21750. This is start from here. 1710. This is 1710, and this is 1750, which is ester. So that's why alcohol is absent, carboxylic acid is also absent, and ester is formed. CN changes, nitrile is at 22. There is no visible peak seen at 2200. So that's why it is also incorrect. C option is correct as well. So this is all about of 2024 Feb March paper. Markings, this is we get the online, and there is no marking scheme available on the net. So hopefully you understood all these questions. If you understood, please like the video and subscribe the channel.